Hi, in this video we will learn how determinant can be used to determine if a linear system has unique solution or not. Well, I will start with recalling few facts. Assume that A is an n by n matrix, score matrix. Then we know that AX equal to B has a unique solution for any given B, for any given vector B, if and only if the rank of A is full rank, so rank of A is n. Well, in other words, this is equivalent with saying that row reduced echelon form of A is identity. And we know that that means that A is invertible. But invertibility has a condition, has an equivalent version when you bring in determinant. It means that determinant of A is non-zero. This is if and only. So combining all these things, or in other words, just not seeing what is happening in the middle steps, which were these guys here, you see that we have proven that theorem that for a square matrix, A, the linear system AX equals to B has a unique solution for any vector B if and only if, so it is equivalent to matrix A having non-zero determinant. So that's just translation of different thing, but shows that determinant can be used to in solving a system of linear equations. Well, let us see this in some examples. So we have few linear systems. Then the question asks if determine if these systems have unique solution. Well, it means what? It means that check if the determinant of the coefficient matrix here is this guy 1 2 negative 1 1, and we know that the determinant, let us call this A, determinant of the coefficient matrix is 1 times 1 minus negative 1 times 2, which is 3. It is non-zero. That means that we can conclude that the system, the linear system, has unique solution for any B, in particular this B here, 2 1. How about this one? Okay, the coefficient matrix. Again, we have to find the coefficient matrix 2 1 0 1 negative 2 1 4 negative 3 2 is the coefficient matrix. And then we have to find the determinant of this matrix. Determinant of this matrix, expand along the first row. This will give us 2 times determinant of that submatrix, which is negative 2 times 2 minus 1 times negative 3 minus 1 times 1 times 2 minus 1 times 4 plus 0 times another determinant, but it will be 0 at the end. Here, this is negative 4 plus 3. This will give us 1. 2 times 1 is 2 minus. This is 2 minus 4, negative 2 plus, and that is what I found before. This was supposed to be negative 2. Yes, because this is negative 1. And then you add, you get 0. So it means that this system, the matrix A is not invertible, and then you can conclude that no, the system does not have unique solution. And does not have a unique solution has a meaning, very clear meaning. It means either it is inconsistent, means that it has no solution, or if it has a solution, it has infinitely many solutions. Okay, let's do the other one. Here we have the matrix, the coefficient matrix, this 1, negative 2, 1, 0, negative 1, and 1. Let's find just determinant of that. Expanding along the first row again, 2 times negative 2 times 1 minus 1 times negative 1 minus 0 times the determinant, so I don't need to compute that one. 1 times negative 1 minus negative 2 times 0. And this one gives us 2, well here, this is negative 2 plus 1 is negative. So this will be negative 2 minus 0. And this guy here, this is negative 1 plus 2. This is, yes, this is 1. And then times 1, this will give us 1. And together, this is negative 1.